distribution, and it's used in statistics. So you can start by writing this down in your notebook and start taking notes on this. What a normal distribution is it's a curve that is going to look like this roughly. And it's, some people might call this the bell curve. It's symmetrical. So you could split it right down the middle. It has what's called two parameters. And those are the two things that are really important that kind of describe it all together. One is the mean. That's the mean or the average. The other one is a thing called the standard deviation. And that's really how spread out the data is. Okay, that's how spread the data is. And I should write that a little bit better so you can read it. Okay, so that's the spread of the data. Just so you know, that we use a lot of, in math, we use a lot of Greek letters. This is called mu. It's a Greek letter mu, and that's used for average or mean. This is called sigma. And it is I think it's sigma. That might be rho. Let me make sure that that's not rho. Let's see what rho looks like. Oh, I think it's sigma. Yeah, sigma. So it's sigma. I thought it was sigma. Anyway, it is sigma is the used for the standard deviation. The things that when you write a normal curve and you describe it, you would have n, and then you'd have the mean, whatever that is, and then the standard deviation. So you really want to label a diagram like that. The other thing that you should know about this is that the mean is right in the middle. The mean splits it right down the middle. So half is, 50% is over here and 50% is over there. Okay. So one of the things that, because this is symmetrical and because the standard deviation describes how spread out the data is, we can draw a normal curve and talk about different parts of this normal curve. Now, depending on on what happens with the normal curve, if you have, so this would be n, and I'd have mean, standard deviation. You always want to kind of describe a diagram like that. You really want to have this label up here. It tells the reader that this is a normal curve, and it tells the reader what the mean and the standard deviation is. So a couple things that you know on this. You know that the mean is right here. Okay, the mean goes right there. So if you think about that, that splits it right down the middle. Now, if we go one standard deviation away, up here, we go plus one standard deviation from the mean. What we end up getting is we end up getting 34% of the data is right there. Well, since this is symmetrical, that means if we subtract one standard deviation, that's also 34% of the data. So this whole amount right here is 68% of the data. Now, if we keep on going with this and we say, okay, what if we go 2 standard deviations out, so up 2, what happens is this spot right here is 13.5% of the data. That means if we subtract 2 standard deviations, this part right here is also 13.5% of the data, which means if you go 2 standard deviations away, you're dealing with 95% of the data. Lots of businesses use this when they're filling jars or something like that, where they want to be in a certain amount of quality control. The last thing is if we go 3 standard deviations. And that's kind of the standard thing, that we go 3 standard deviations either way. This is 2.35% of the data, and this is 0.15% of the data. So really small out there on the tail. So if we subtract 3 standard deviations, again, this is 2.35%, and this is 0.15%. So if you go 3 standard deviations away from the mean, you're dealing with 99.7%. So again, if you're 3 standard deviations away from the mean, you have almost everything that you need. So we'll talk about this, what this looks like in an example in just a second.